Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the fourth lecture of this week of this online course on understanding and reducing greenhouse gas emissions, and we are focusing on scope 1 and 2 emission reduction through building design and construction. In this lecture today, we are going to look at tools for calculation of GHG emissions, and quickly looking at the recap of previous lecture, we looked at the different approaches to accounting methods, their definitions, and then we looked at GHG project accounting concept, a lot of key concepts we looked at. Then we went through the steps for accounting and reporting for different standards and different types of products and activities, and finally we looked at the examples of accounting and reporting, very small scale examples though. In this lecture, we are going to look at the different categories of GHG protocol tools that are available, because we are largely going to be talking about the calculation tools, and we will look at examples of calculation tools. I am going to be picking up one tool which is available online by UNFCCC. It is a comprehensive tool, a cross sector tool which can be used by any business, but it is also generic and may not be very specific to the business. So, may not be of use to a lot of businesses, and also an individual GHG emission calculation tool. So, that is what we are going to cover in this lecture. Let us start with the introduction of these different emissions that are going to be requiring calculation and hence the tool for that. So, this is just a recap. We already have seen what are the different types of emissions that take place, the direct emissions. So, we know that the emissions are primarily falling in the 4 categories. So, one is the stationary combustion, second one is mobile combustion, process emissions and fugitive emissions. Depending upon the business type, depending upon the industry, the emissions will vary. We may have industries or we may have businesses which will not have one particular type or some types of emissions at their sites, while certain others might have all of them. It totally depends upon the activities which are coming under the organizational and operational boundary, and depending upon the business goals. So, we have to know these first, and then we have to know what are the specific calculations that are required. So, also there are 2 approaches when we go about GHG accounting. The large businesses often will have multiple offices, multiple sites across the geographic area. So, there are 2 ways in which we can calculate the GHG emissions for all of them, because when we say the company is reporting XYZ whatever company, it has hundreds of offices. When the company is reporting, it means all 100 offices are reporting. So, they could report in 2 ways. One, they could send the data to the parent company and then they can do the conversions, they can do the calculations, and then they can calculate the GHG emissions, or each site can calculate its own GHG emissions and then they can, the parent company, the company can report the GHG emissions. Both have its advantages and disadvantages. Here in this case, we need people to be able to understand the data that is coming in and then to convert, to know the emissions, convert into emissions. So, we need more manpower here. In this case, we need centralized manpower. So, this is centralized, we need centralized manpower. Here we would need decentralized manpower. The data in both the cases has to be collected in a decentralized manner from each specific site. But the advantage with a decentralized one is that they also know the benefits or the performance indicators that are resulting from the GHG emissions data, because they clearly know that how much of emission reduction has happened on their site and eventually to the bigger company that they are part of. So, there are benefits and also there are disadvantages of this approach, but either of the 2 approaches can be used when we are doing the calculation. Now, going ahead with the GHG categories of GHG protocol tools for calculation, So, we know that this is from the types of emissions that we have seen. So, the category of tools also respond to these emissions. So, stationary combustion. So, we could be the tools could be looking at specifically the CO2 emissions due to the stationary CO2 emissions resulting from stationary combustion for different processes. So, each specific process and the tool for that, and similarly for each of these. There are a lot of tools that are already available and they are available on different platforms. You can continue to look at the link that is given below, and you can go to these links. You will find a lot more information on these web pages, and several tools are there. Now, these tools, the categories of calculation, the emissions remain the same, but these tools, depending upon the scale and applicability, may be categorized into these 4 categories. One is cross sector tool. They can be used by different sectors regardless of the business that they are offering. So, these are generic tools. So, one of such tools I am going to show in the lecture later today. The other one is a very large scale tool, which is country specific tool. So, we will see not going to see the examples, but I will show you that there are several country specific tools which are available. There are sector specific tools. We have seen already that cement industry tool, we have tool for aluminum industry, we have tool for iron and steel industry. This is for India itself that we have. So, we have sector specific tools that are available, and then we have tools for countries and cities. So, for countries, so not country specific, but for countries and cities, for governing areas. So, that is also what we have. These are the 4 categories. You can look at the web page of GHG protocol, and there you would find, for example, cross sector tools. So, this is for stationary combustion. It is for stationary combustion, but is valid across the sectors. This is for cross sector tool. This particular one is emissions from combined heat and power. This is for uncertainty of GHG emissions. How can we measure and estimate the uncertainty of GHG emissions? That is also that requires a separate calculation. So, all these tools are available under the cross sector tools. We have country specific tools, for example, Chinese coal fired power plants tool, or for example, CO2 emissions from the production of cement, the Chinese version. So, for example, paper and pulp tool customized for Mexico. Why country specific tools are required and are there, as I had explained earlier also, for different contexts. The fuel type might be different, the machines might be different, the efficiency which is obtained, which is achieved due to the use of specific type of machine may be different. Now, to account for all those, for example, if you look at the road construction industry. Now, in India, if you look at any road which is being constructed, you will see that a lot of manual labor is used still, not for highways, but for smaller roadways. However, if you go to the developed countries, the entire work is happening on machines. The machines are doing all the laying and leveling and everything, and it is very less of manpower that is being used. Now, that itself will make a difference in the total emissions that are resulting from this particular activity, which is say road laying, and similarly all activities will have country specific emissions. For certain activity replacements, the emissions will be more or less, and that is accounted for the specific country. So, country specific tools, and then we have sector specific tools. Now, sector specific tools are very obvious because there are different set of activities altogether. If we are talking about aluminum, so the extraction of aluminum from its ore requires a different set of activities, the washing with different chemical processes, and they will release different set of gases which are going to be very different from, if we say we are talking about a food processing industry. There the processes that are going to take take place and the resulting GHG emissions are very different. So, the sector specific tools are very important. However, within that there may be difference in the emission factors for specific countries. So, these are sector specific tools, and then finally, we have tools for countries and cities, where we are looking at the data for a larger governance area. For example, the policy action standard calculation tool. Now, this is for countries and cities, they can be using it within their governance area. Now, I am going to take you through the example of a calculation tool, which is called greenhouse gas emissions calculator, which is prepared by UNFCCC Secretariat. Now, it comes with a disclaimer that this is going to be a generic use calculator, though it has emission factors. The values that have been used for calculating the GHG emissions are actually coming from standard resources or research papers or research resources properly published. Yet, when the reporting has to happen, if reporting has to take place, then specific calculation for GHG reduction, emission reduction has to be done. What these calculators do, it helps it to at least list its activities and have an idea of the range of emissions that is accruing. So, we will look at this calculator. Now, it comes with this disclaimer that the accuracy, completeness and suitability or validity of the information is not guaranteed, but it can be used for reference purpose. Now, it also has a tab on info and resources, and if you look at this, so from where the factors, the emission factors have been taken and all the reports which from where the emission factors are coming are given, and if we go to each of these reports, we will also see what is the method, what is the methodology that has been adopted to arrive at a particular emission factor, which can help a business in understanding whether this emission factor is relevant for my business or not. Even if not, we can still go ahead with using the tool and estimate a tentative amount of emission that is resulting because of change of activity from baseline to reporting period. So, it is very easily done using tools like this. Now, here, so we start with putting the details related to your organization, and very interesting thing that you will find here, the moment we choose the country from this list and I say India. So, now that we have country specific emission factors, automatically in rest of the sheets, it automatically takes the emission factors that are coming from this from selecting the particular country. In case the country specific emission factors are not available, in that case the default emission factors that are given by UNFCCC and IPCC are put in. For countries where specific emission factors for their countries for that particular activity is available, then those emission factors are used. Now, here we are clearly mentioning about the number of employees. Now, let us look at some of the tabs that are there. So, this first tab is requiring us to answer what are the different types of fuels that are consumed. It is automatically coming with a factor. These are the default emission factors, because I did not select a country. Had I selected a country, these default factors would automatically change. We cannot change them, but these default factors will change. Now, that is where I was saying, for example, there is a new fuel that is being used in the company. Maybe a research company has developed a biofuel and it is using it the biofuel which it is producing on its own for the operations. Now, the emission factors for that will not be available here, and a lot of other data that can, for that specific calculations will have to be done and then the reporting. But the first thing that we are accounting for here is the fuel that is used now specifically in owned or controlled stationary equipment. So, we are not talking about the combustion of fuels in transportation devices, because that is the stationary combustion. that is the mobile combustion. Now, here we are talking about stationary equipment such as boilers, furnaces, burners, turbines, heaters, incinerators, etc., which means that it is going to go in scope 1. So, the fuels that are going to be used in such stationary equipment are what we have to report here. So, they have already given a lot of options: gaseous fuels, liquid fuels, solid fuels, and all the possibilities that are there along with their conversion factors. We just have to mention the amount that has been consumed for whatever year you want to do it, for baseline year or reporting year. We mention that and we get the equivalent carbon dioxide emissions. The second tab is for bioenergy. Now, this is for combustion of fuels that are produced from recently living sources at the site itself or in an asset that is under the direct control. So, in case, that is what I was mentioning just now, that if there is a company which is producing its own fuel, so in that case also it is giving us this option, but not all might be covered and we might require to calculate it separately, but it allows us to account for biofuels. So, and that fuel will also be consumed. So, combustion of this fuel which is produced at the facility itself, not procured, this is what we will take into account. Then we have refrigerants. This is fugitive emission that we are talking about from leakage from air conditioning and refrigeration units or the release to the atmosphere of other gases that have a global warming potential. Now, these are fugitive emissions. So, in a particular year, suppose we are reporting it for this year 2023, if fugitive emissions have taken place, if there has been a gas leakage or if there has been a gas replacement, it could be a small facility, for example, my residence. If I get a refilling of the gas for the air conditioner done, so that is going to be mentioned here. We have to specifically know that which gas is being used, which refrigerant is being used, and then we mention and look at the factors here. We did discuss in the initial lectures the potential of these refrigerants, these HFCs or the other refrigerants in causing global warming. So, we have compared to 1 unit of carbon dioxide, if you look at the potential, we have SF6 sulfur hexafluoride, which has a global warming potential 2200 times that of 1 kilogram of carbon dioxide. So, these fugitive emissions might be very small in quantity, they might be very small in number, but their potential is significantly higher, and hence there is a specific mention or tab for tabulating, calculating and measuring that. Then we have the electricity, heating, transmission and distribution losses and district cooling. Now, if you remember clearly, this data will help us in calculating the scope 2 emissions. So, what we were doing here for refrigerant, for bioenergy and for fuels, these three were the direct emissions, and we were talking about stationary combustion, we were talking about fugitive emissions, we were talking about process emissions. Now, here in this particular sheet, the industry emissions, we have not talked about the industry process emissions so far, but the other two types of emissions are already covered. Also, the emissions due to transportation is going to be coming later, but this particular in between is for scope 2 emissions. So, we are talking about how much electricity is being purchased from the grid. There is also a possibility that we can have our own emission factor put in. Then how much of heat and steam is purchased in case it is supplied centrally and only heat and steam is being purchased, or if only cooling is being purchased from district cooling. So, all these three we put in. There are already the transportation and distribution loss T&D factors which are already factored in. It adds it automatically in case there are renewable energy contracts. So, though we are purchasing it from the grid, but we also have a renewable energy contract, which means that we are paying to produce renewable energy somewhere or are purchasing a part of the electricity as renewable energy. So, it would automatically take into account this and modify the emission factors accordingly, and then we will get the overall carbon dioxide emissions for electricity, heating and cooling and transmission and distribution losses that are happening. This is scope 2. Now, going ahead with the transportation, now we are talking about combustion, the mobile emissions, combustion. So, this is from the fleet of vehicles that are owned or directly controlled. So, we clearly know that if we have 100% control, if we have equity, financial control, so the emissions that are resulting from those activities are also going to come under the direct emissions for this company or scope 2 emissions for this company. Now, here what all type of vehicles do we have, how many, and the units, the kilometers that they run, we have the fuel, so distance, how much that they run, and the vehicles that we own. So, together will give us the emissions. So, we could be doing it for an year. So, we could be doing it for a day average and then multiplying it by 365 or whatever number, or we could be doing it noting the data for every day for an year, if that is how monitoring and accounting is happening in certain countries, certain companies. It totally depends upon how the accounting has to be done. If it is average for the baseline, the average will continue to remain the same for the reporting period. We may change the distances also. For example, in the baseline year, we had more of cars which were given to employees, and in the reporting year, the change that was there, the project activity was that there was a company bus, an electricity EV vehicle, a bus which is now bringing the employees to the office collectively. Now, there will be a significant change from then to now. The kilometers will reduce for each vehicle, the number of vehicles will reduce, and hence the overall reductions can be calculated. So, this is for owned vehicles, and these are scope 1 emissions because they are going in direct emissions, which is owned or controlled vehicles. This is WTT fuels, so well to tank fuels. Now, here we are talking about the production of fuel. So, this is not going to be relevant for all the companies. For example, an institute might not be finding it relevant, no data here. However, for certain companies like petroleum companies, big petroleum companies, they might be talking about well to tank. There are other companies which are only distributors, they purchase the fuel in between, not from well to tank, but from the storage unit to the tank of vehicle is what we are talking about. So, here we are talking about the emissions that are associated with extraction, refining and transportation of the fuel resources to an organization site. So, that is what we are talking about. All these are primarily, this particular tab is relevant for the extraction companies, the petroleum extraction companies, the fuel extraction companies, and we would find a lot of different fuels here. We are talking about CNG, LNG, LPG, natural gas, we are talking about the diesel, fuel oil, gas oil, petrol, processed oils, waste oils, natural gas. So, we are talking about all different types of fuels that are used in the world today, but this tab is relevant only for companies which are in the business of fuel production, extraction and supply of that, but not the sale of them maybe. Some companies might also be involved in the sale, but here, so this is also going to be coming under scope 1 for companies which are in the business of extracting. For example, we have a company, if it is not extracting, but if it is using the fuel, then those factors have already been considered here in the fuel, or if this fuel that is being produced under WTT is going in owned vehicles or fuels. So, it will automatically be accounted in the scope 1 of those companies, which is actually coming from this maybe. So, not necessarily it is relevant for every company, but depending upon the scope of the activity within your organization boundary, we can select them. Now, we have material use. So, what are the different materials that are going to be used? Now, this is the emissions over the extraction, primary processing, manufacturing and transporting materials to the point of sale. This is similar to the calculation tools that we found for aluminum or steel or glass, specific calculation tools like those. Here we are talking about the different types of materials that are going to be consumed for including extraction, processing, manufacturing and transportation of these materials. So, these are for example, wood as a material, extraction, procuring it from the forest, processing it if it is processed and then transporting it to the point of sale. All the emissions related to that are accounted for here. Now, this also gives us, even if we do not fill up the data, this gives us a very clear understanding of which materials are energy intensive or emission intensive and which ones are not. You can look at the natural materials and then you can compare them with the materials which have the high emission factor value. So, we are looking at plastics, the PET, look at metals which have aluminum in them, look at the batteries that we use so often, electrical items, the IT items, they consume a lot of energy during the process of extraction of the base material, clothing which we understand. So, a lot of synthetic clothing is there. Organic materials of clothing do not have this, but currently around the world a lot of synthetic materials are there and this is a significant producer of emissions. So, fashion as an industry is highly emission intensive, which does not appear, but it is indeed. And look at the materials which are very low on emissions. They are, most of them are the natural materials. For example, you look at aggregate which is going in the concrete, or you look at compost. It is not zero emission because there is methane being produced from the composting, from the compost during the composting process, but these are very low on emissions. So, we know that anything that is processed is high on emissions, anything that requires less processing is low on emission. So, one is that we would know that how much emission are we really causing, but at the same time it also helps us in selecting, making the right choice, judicious choice if we really want to reduce the emissions. Similar thing is with waste disposal. So, all different types of waste that has been disposed. Now, the disposal of this waste, if it has to be done properly, also requires significant amount of, it causes significant amount of emissions. So, if you look at this disposal of this waste, board, the paper and board, mixed paper. So, this is all going to cause significant amount of emission even during its disposal. Whether we dispose it scientifically or unscientifically, it is going to release certain significant amount of GHG emissions. Then we are talking about again the scope 3. So, this is flight and accommodation for individuals who are working, flying for business purpose, academics, work purposes, depending upon the business goals and activities required for different businesses. So, it is, we just have to input the destinations and the origins, and we will know the total distance that has been travelled, both ways, single ways, and accordingly it will give us the equivalent carbon dioxide that is released for flights, air travel. And then hotels. So, emissions that are associated with overnight hotel stays for work purposes, it is counting the emissions that are going to accrue. Now, this is all going in scope 3. This is not in scope 1 and 2, this is largely going in scope 3, but we have to become very conscious and aware of where the emissions are coming into my systems. So, it might not occur directly to me that okay, business travel is also causing so much of emission, maybe not directly at the site itself, but overall it might be causing emissions, and depending upon the business goals, we may choose to reduce or cut down on these emissions depending upon the data that we get here. So, the whole point is in measuring these emissions, and once we measure, we would become more aware that what all could be causing emissions. This is not exhaustive, there are more heads that could be added for your particular business, but this gives a fair idea as to what all is possible. Then we have business travel through land and sea. So, that was for air travel, this is for travel by land and sea, and accommodation has already been covered. So, different types of possibilities of travel are already given here. Then we have freighting. So, if transportation shipments that are going to take place, if that is happening by land, sea or air, so that is through a third party, but of the products that are owned by the company. So, the emissions due to that freight are calculated here in this one. Then we have employees commuting on a daily basis, not for business purpose out of the city or out of the office, but from home to the office. So, how many passengers are commuting, how are they coming, all that is also accounted for here. This is again scope 3 accounting that we are talking about. Then food. This is food provided by the organization to be consumed by the employees. Now, it may not be relevant for a lot of organizations where food is not being provided, but wherever the mess, the canteen is being run and the food is provided, there we are talking about the emission factors. Now, again here you can look at the emission factors difference between the different types of food items. If we look at meal with beef, the emission factor, and compare it with a vegan meal or a vegetarian meal and check the emission factor, it is almost 3 times. So, we make the choices right depending up if the intent is to significantly cut down on GHG emissions. So, being more aware, knowing where the emissions are coming from will help us in also cutting down these emissions. So, this is a comprehensive calculation tool that has been provided by UNFCCC, and whether we are really going for reporting or whether we are really planning on certain activities for GHG emission reduction or not, at least by starting to measure the GHG emissions, even not for reporting purposes, only for accounting purposes, will help in making the process of emission reduction easier and the uptake of this whole idea much easier. So, similarly, we have these heads where we are talking about home office, where it considers the energy consumption of workstation, lighting and cooling or heating. So, what we are assuming here is a 5-day week where the office is going to work, type of home office where the people might be working from their homes. So, that is also included in this one. For the other, the office itself, we had already looked at the overall electricity consumption, heating, cooling, but here especially after the pandemic, we have seen there is a surge in work from home culture, but the employee who is working from home office is also consuming electricity, is also adding to the emissions for the company. So, this is also going to be a scope 3 emission, or the electricity emissions will actually be used as scope 2 emissions. And then we also have water. So, the water that is delivered through the main supply network is going to be calculated, and for the supply and distribution also the emissions will be accrued. So, these are not comprehensive, as I say again, a lot of processes, the emissions for processes, they have not been included in this one, but this is very generic calculator, cross sector tool which can be used by any corporate. Barring the industrial processes, it covers most of the heads that will result in GHG emissions. So, that is what it gives us, and I would encourage all of you who are attending this course, this lecture, to check this tool and try to calculate the emissions for your own company. We will realize that a lot of emissions actually go unnoticed. We do not even notice them, we do not know that these emissions are really happening, and measuring is valuing. When we start measuring, that is when we start valuing, and this is what we are talking about all this while. Start measuring, accounting and report when we are sure that the process has been transparent, it has been complete, and that is when we can report that we have been able to reduce the emissions. So, there are several similar tools that are available. They have been developed by individual companies, by sectors. This one is developed by UNFCCC, as I mentioned, and is open and available to everyone. Some tools are specifically developed for the company's internal use. So, you will find a lot of similar tools on the internet. Please go through these tools and look at the emission factors, go back to the reports and understand the approach that they have adopted, the methodology that they have adopted to arrive at these emission factors, or where from are these emission factors coming. Also, be very observant to the different types of activities and the options that are available, as I was mentioning, the choice of food, the choice of material, the choice of clothing, everything, these small things are actually making a lot of difference in overall GHG emissions or our footprint on the planet. So, with this I will stop here, and we will try to look at some examples in tomorrow's lecture, which will be the last lecture of the week. Thank you very much for being with me. Bye bye.